So drip irrigation is something that over the years, as I've worked in various areas of the industry dealing with irrigation, from greenhouses to landscapes and agricultural settings, it's been something that it's taken me a lot of years to kind of figure out what are the basics of drip. And I've worked with a lot of homeowners in my job and with a lot of agricultural producers as well. And there's a lot of misconceptions about drip, and there's a lot of ways that people screw it up and make it not really work very well, or it's not doing what they think it's doing for their plants. And so that's kind of why I titled it Demystifying Drip. I think too that there's a way to simplify drip irrigation. If you go to the store and look at the offerings of parts that they have at the home centers or the sprinkler supply houses and stuff, it's overwhelming a lot of times with the different options that they have. And so hopefully we'll clear some of that up and simplify. And I've got some tips on ways to simplify. And I practice all of this. I have lots of different types of drip in place at my house, from containers to grow beds to shrub beds. And so I use this, and I've done a lot with it professionally as well, and I've done a lot of greenhouse type of stuff as well. So brief history though, in about 100 BC, from where we have records up to about the mid 1800s, it was pretty popular during that period to bury clay pots, and they're called oyas. And the clay is porous, and so it would, as those pots were filled with water, it would leak water into the surrounding environment. And there's still techniques where they use that today in the Southwest particularly. In the mid-1800s, as clay pipe began to be manufactured, that same idea was extended to larger scale production in filling pipes buried in the ground with water. So the same idea of the clay pot, but now expanded into much larger sections with clay pipe. And then in 1920s in Germany, they began experimenting and developing perforated pipe that would kind of do a similar thing, but the pipe wasn't as porous without the holes drilled in it. And then in 1959, there was two Israeli inventors that patented the first practical plastic emitter using a friction pathway. And I'll kind of show you what that means, because the basic premise of drip irrigation is based on a friction pathway. It's how they slow water down to only drip out of a pipe. And so it's pretty interesting technology. Let's see if I can get this. This clicker doesn't want to work. Will you just click me forward one slide, please? So in 1960s in the United States, there was a man in New York named Richard Chapin who invented the first drip tape. He called it dew hose. Oh, go back. Can you go back one? There we go. And drip was developed for agriculture. That was the industries that they were trying to serve. And Chapin, and there was a company that he built called Chapin Watermatics. It has now been incorporated by a company based in India called Jain Irrigation. But he created a company called Chapin Watermatics, and they did a lot of work in developing drip systems for third world countries and agriculture and undeveloped countries. And so they were really very instrumental in kind of developing a lot of this for agriculture. And so as drip irrigation was originally developed for agriculture, and then it's been adapted and modified for use in landscapes. And I asked the question down at the bottom of the slide, is it a good fit for landscapes? And that's a valid question, because there's a lot of pros and cons about using drip in landscapes. And so hopefully we kind of come around through this discussion, you'll be able to reason this out and say, is it a good fit for my landscape? And then to the present day, there's lots of developments in micro irrigation. There continues to be companies that are developing new products and new ways to use this technology and increase the confusion that there is on the store shelves. But basically, there's turbulent flow emitters, pressure compensating emitters. They're more durable. We have better pressure regulation to make them drip the way that they're supposed to. That we have better filtration so that they don't get plugged as easily. And we also have added micro spray to that, more on that in just a minute. Subsurface drip, that is burying the pipes below the surface, anywhere from 4 to 6 inches typically. And then also there has been developed a lot of confusion, and that's what hopefully I'll be able to address some of that today. So will you advance me a slide? So I wanted to put in a slide here about microspray. We're not talking about microspray at all. Microspray is not drip irrigation. It is a way for manufacturers to make money and to really screw up drip irrigation. If you mix drip irrigation, what's true drip irrigation with microsprays, you don't have anything that you can really schedule or figure out your water usage very well, your precipitation rates, all of those, because they don't talk the same language. You have vastly different output rates for micro sprinklers than you do for drip irrigation, and they don't work together. So they have different flow rates and coverage areas. Most micro sprays have adjustable flow rates, so it's very hard to gauge how much water flow you're going to need in your pipe. It's very easy to put too many of them on a system because you can't put nearly as many of these micro sprays on a line as you can emit drip emitters. Where a spray like this might put out 5 or 10 gallons an hour or more, but the typical drip emitter puts out anywhere from a half to about 2 gallons an hour. So they're very different in the way they put water out. They're also extremely prone to wind drift, typically because they produce a small droplet size. And they're also very exposed. They're prone to vandalism, they're prone to being tripped on, and they're very prone to expansion and contraction because they're above ground. So when the sun comes out, it expands the pipe. And when the sun goes down, the pipe cools and relaxes, and it tends to pull the stakes out of the ground. It can pull the tubes out, the micro tubing out of the main line. And so there are some challenges with it. And several years ago, I tore out all of the micro spray and everything I had in my yard and simplified it. And we have a question here in the room.
The bottom picture, is that a micro spray that's...
Yeah, so these two pictures are just two different types of micro sprays. So the one on the top is one that has about, I think it's 16 little individual streams of water. And then they actually then create just a wet pocket that hopefully then eventually merges with the wet pocket next to it. And the one on the bottom is one that produces more of where you see the cone of water in the middle. So it actually puts out a lot more water per square foot than the one at the top. That one at the top will spray about 15 feet. So putting it in with a drip irrigation system, which is a targeted type of system, it just doesn't fit at all. The ones at the bottom there, they only spray about 3 feet or so. So they're not, there are just so many options. So for this presentation, I'm leaving the discussion of microspray out of it, and I'll leave it with this, that if you want to use it, I'm not saying don't use it, just don't call it drip, and don't integrate it into a drip system. Put it on its own zone, have a zone of just drip. I mean, a zone of just microsprays. And that picture at the top and the picture at the bottom are both on irrigation zones where there's no other drip, it's just spray. So we've got a raised bed on the one on the bottom, it's watering a raised flower bed, and there's one of these little sprinklers about every 6 feet. And on the top, that's watering a small orchard, and there's about 15 of those, well actually there's probably about 25 of those in this orchard, all spaced about 15 feet apart. And that's it. There's no drip. It just worked out the best for this situation because we couldn't put drip in. There's a lot of people that go into these areas and having all those drip tubes running all over the place. So we just decided to simplify it and put in these micro sprays instead. So, but that's all I'm saying about micro spray. You want to advance me? Okay. So as I said, it was originally developed for row crops. Things like onions, peas, beans, corn, tomatoes, this is still where it works best. It really does a nice job with those kind of things. And then there's two different kind of ways that we look at drip. One is what's called inline drip, where the emitters are built into the piping at equal intervals. Then we have a variation on that called the soaker hose, and that's what's pictured here. Sometimes they're also called dew hoses or weeping hoses. And they're usually made out of recycled rubber, and they leak water throughout various pores throughout their length. And they tend to emit about a gallon of water per hour per foot. But that varies a lot based on the pressure that the water is coming through. So question here in the classroom.
So they don't last that long.
They don't last that long. And I was gonna bring that up. This was my first foray into drip over 20 years ago, was trying this stuff. And I think I got 2 years out of it in my corn patch. And so on the packaging for this particular pipe, it said it would last 7 years. And I'm like, not in Utah, it won't. Because we have really high light intensities here. So 2 or 3 years is about all you can expect. It does just start to crack, and then you get lots more water output than you really want to have in that area. And then point source drip, this is where we have emitters added to the pipe to water small individual areas, and this is where I think what most people think of when we talk about drip. And so this is common for shrubs, trees, perennial gardens, bush vegetables, containers, hanging baskets, things like that. So go ahead and advance. So there's obviously potential for water savings here, and that's why it's promoted a lot, especially in years like we've had these last several years where we've been in a drought, and that's that it can reduce water usage through reduced evaporation, reduced runoff from the soil surface, better distribution uniformity. That is, how well does it spread the water out over a given area. The distribution uniformity of drip is about 90 to 95% if it's set up right. Whereas the typical distribution uniformity of an irrigation system, if you do a really, really good job, you can achieve about 80%. So you just have a lot more uniform water distribution in an area with drip, especially if you use the inline drip. Reduce water for weeds, especially if you're using point source drip, because you're not watering the areas as well between plants. And so for rock gardens and things, it's a really nice fit there. But it's not automatic savings. And I have worked with people before that are killing their plants by overwatering them with drip irrigation. So it doesn't matter how we deliver the water, if you're still not scheduling it and understanding how much water it's putting out, you can still put out just as much water as you were before if you're switching from drip to sprays. So go ahead and advance me. Is there a picture with this one? Will you push the button again and see? No, okay. So other pros and cons then are that you have to have clean water, and so that's where the filters comes in. Even if you're on city water, it's recommended that you use a filter for drip, and that's because most city, I grew up in Orem, and we always had sand coming through the system. We'd find sand in our drinking cups all the time. And that's just the nature of it. There's never going to be 100% way that they can keep all the debris that's going to make it through the tap in your house. So question here in the room. Yeah,
are you saying it's not recommended to use secondary water at all?
No, I use secondary water. You just filter it. Yep, and we'll talk about filters. That's one of the first things. It requires low pressure, which can be both a pro and a con. So if you have low water pressure, drip can be a great solution. But if you have really high water pressure, then you have to reduce that pressure, or it tends to blow the lines up or pop everything out. So here in Utah, where we get a lot of our water from these reservoirs and things that are up high in the mountains, we typically have high water pressures for our irrigation. So the pressure at my house in Saratoga Springs is about 100 PSI. That's way too high for sprinklers, and it's especially way too high for drip. So it ruins valves, it blows sprinkler heads out of the ground, and it also blows the drip irrigation pipes up. So we have to bring that down. It also works well under mulch. We don't care if the top of the mulch gets wet. We just care about that soil surface underneath it, and that's mulching is another way to increase water conservancy. It also can be buried, although that fad has kind of vanished now for quite a few years. It was a popular thing for landscapers to do buried drip or grid drip systems under lawns, and it came and went because when they plug up and you start having dead areas of the grass, you have to dig up the lawn to replace the drip, and so it just wasn't sustainable long term. And it's way, way, way more expensive. It's roughly probably 4 times as expensive to install a drip system underground for like a lawn than it is to put in spray heads. And then the accessibility for repairs is also much easier with spray. It may help reduce weeds. It provides precision application, which means, again, that you may not be watering weeds and runoff into other areas. And it also can help with plant disease in that you just don't put the water on the plant leaves and things like that. So it tends to keep the humidities lower around the plants and keep it off of the water off of the leaves so you don't get as many fungal or bacterial diseases. All right, next slide. So tools, we'll start with tools. Luckily there aren't too many that are needed. So one of the things that you'll need, one of the main tools is a punch. So the pipe that we work with is plastic. It's usually fairly soft. And the fittings that go into this are designed to fit into a hole that has been made in a flexible plastic pipe. There's lots of different styles and sizes for different dripper diameters, but the typical one that you'll see in the stores, unless you're getting into some specialty agricultural products mostly, is a 1/8 hole or something thereabouts. For a 1/4 inch drip fitting is the most common. So the 4 that are there, those are the ones I have in my toolbox at my house. The wooden one there, I actually made that from a dowel and a nail, and I actually found that was the cheapest way to go. I've done a lot of greenhouse irrigation where we might be putting in several thousand drippers on benches in there, and so we wanted something that was a little bit easier to hold and a really sharp point on it. So the one on the bottom on the left picture, it's actually a hollow coring tool. It will actually punch a hole. It'll actually remove a piece of plastic, and it works really, really well. But I will say that if you use a punch that is like the 3 up above that just pokes a hole in it, you will actually have better sealing around the fittings that you'll snap into the pipe because there's more pipe to push back and try and close the hole back over. So that's just my personal experience. The one on the bottom right there, that's a commercially available tool. You can see it actually just fits over the pipe, and then you squeeze the handle and it punches the hole in there, and that can be great for limited mobility, those kinds of things. And then you can see the blue half circle in the bottom where the pipe fits down in there. That actually comes out, and you can use it through a 3/4 inch pipe, or if you put it in like it's shown in the picture, you can use it for 1/2 inch pipe. So it gives you that option to work with 2 different pipe sizes. So I bought that to try it because I had my kids help me do some punching one time, and we found that it was a lot more cumbersome to use that than just a little hand punch that was nice and sharp. So, but there's lots of options out there, and I just wanted to present a few of them that you'll run across and just touch base on it real quick. So next slide. Pipe cutters. So the plastic pipe that we use for drip is also called tubing. And so on the picture on the left, the red handled one, that can be used to cut this kind of pipe, but it's actually designed for rigid pipe like the white PVC pipe. But you can use it to cut this other tubing. It's just not as fast. And then the other 2 are more like a scissors style where the blade just cuts through the pipe. Now, the one on the right is a multi-faceted tool in a sense, is that not only has the pipe cutter on it, but it has a punch at the end, the top end. And then you can see in the picture on the right, it actually has some slots cut in it to put fittings in, to help you snap fittings into pipes, or to snap the micro tubing onto the fittings, or little openings where you can put the drip emitters and use that to punch them in the pipe. Because most of the time you can't get these fittings in with just your hands. You got to use a tool or a pair of pliers or something. So there's different things out there like that as well. And the picture on the left, that one in the middle, that yellow handled one, I've had that pipe cutter for probably 20 years, and I do sharpen the blade with a whetstone periodically, and they'll last a really long time. So next slide. Then there's also different companies that will make fitting insert tools. So I already kind of showed you one with that yellow or that green handled tool where it has different things in there where you can put tubing and fittings to snap them in. Rainbird, just as an example, and I'm not endorsing one product over another. I just have shopped around and just gotten things that are locally available to make this relevant to what you might find if you go to the stores and look for stuff. So, but this is an example of one company's tool. On the end, you can put an emitter to snap into a pipe, and it also has little areas in it where you can put fittings to help you get those into the pipe. And it also has a dripper emitter slot in the side, so you can actually pop drippers out of the pipe if you want to remove them. All right, next slide. All right, so we're going to go through the anatomy of a drip system now that we've kind of covered the basic preliminaries. We'll talk just briefly about automation of these systems, then filters, pressure regulation, valves, conversion from sprinklers if that's applicable to you. We'll talk about some basics there. Distribution tubing, the emitters, and then I put conversion from sprinklers on there twice, I guess, because it's super important. All right, next slide. All right, so where I've had to install drip systems in areas that don't have a valve or we don't have electricity to run a valve like you would on a time clock, maybe that's hanging up in your garage or something, I've gone to battery-powered timers. And this is just one brand. I've used other brands and they work well also. This was just one that will run 2 valves and each on their own zone. And they work really well. Just come up to a hose bib. So if you got a hose bib, and I actually use one of these in my yard as well, where I have a hose bib. I added some raised beds to my yard, and I thought, well, I don't have a way to water these, but there's a hose bib nearby, so I hooked the system up to that, and it runs separately from my regular time clock for my grass and my trees. So you can connect it to your existing valve, use a battery timer or a hose timer, or go manual and just open and close it with the hose bib. All right, next slide. So emitter or filters. So the emitters that we're using in drip irrigation have small openings, and so we need to eliminate the particles that come into the water flow that would restrict those openings or block them. And stuff that passes through, so if it's kind of silty and your filter doesn't catch that, usually that stuff passes through the emitter just fine. Where it gets a little confusing is with the screen measurements, like how much screening do you need to have? How fine does this filter have to be? So, and there's different ways. The U.S., what you'll see a lot of in the U.S. is what a measurement called mesh. And like this is a 200 mesh filter, for example. So mesh is the number of openings per linear inch of screening material. So basically, the more strands they have in the filter material, that's going to make a smaller hole. So if there's 10 wires per inch, or there's 200 wires per inch, basically is what they're saying. So the higher the mesh number, the more openings per inch, and the finer it'll filter. The smaller the particles it'll filter. So for drip irrigation, we need at least 150 mesh. And if you're going to use the drippers that are a half a gallon an hour, which is a really low flow rate, then you have to use 200 mesh, which is finer, because they drip a lot slower and they have smaller openings than the 1 gallon per hour and up. So for most of my systems, I just go with 200 mesh all the way around, and then it doesn't matter what you use. So the pictures on the right, the upper one there showing the metal screen, that's a 155 mesh screen. So that would be a minimum for drip. And then the one with the white filter screen on the bottom there, that's a 200 mesh filter. So it's quite a bit finer. Another way that screening sizes are measured is in microns, which is a millionth of a meter. That's the size of the opening between the wires, and that's more common worldwide than mesh. And then you can also find charts that have inch fractions of openings, but most of us don't really understand how big 0.0032 inches is. And we can't convert mesh to microns directly because that conversion would have to take into account the diameter of the wire that is being used to create the filter, and so there's no one diameter that's fixed for every filter. So you can see that, like the filter up top, that's made out of metal. The other one's made out of a polyester fiber, plastic fiber. So just an example, 200 mesh, which is the filter on the right there, the bottom right, is about 75 microns, or about 0.003 inches. That's how big the openings are. And just for comparison, human hair, on average, is about 70 microns in diameter. So human hair varies a lot. It's actually anywhere from about 150 to as little as about 50 microns. So some people have coarser hair and some people have more finer hair. But that's just to kind of give you the reference of that. Question here in the room, yeah.
How many filters do you need?
Well, good question. How many filters do you need? Depends on your water quality. So a lot of times if you're, say, irrigating from a pump out of a pond, you'll have to have probably 2 or even 3 filters, or a very sophisticated like sand filter system to get most of the debris out, and then going to something really fine like this as a secondary. So if you're running secondary water that's pressurized and coming through pipes in the ground to your house, most of the time you can just get away with 1 filter. But if you're pulling out of a canal or out of a pond, you're going to have a lot of big debris in there that's going to have to get filtered out with 1 or 2 filters that gradually step it down till you get to this fine system. And there are irrigation specialty stores that can help you determine that and help you set that up, because that's a little bit more involved. So another question here in the room, yeah, in the front and then you in the back.
In general, how often do you have to clean them? I know it depends on how dirty your...
Yeah, it does depend on how dirty your water is. My dad in Lehigh, he doesn't have drip in his yard, but he has secondary irrigation that comes out of a pond. And he has, I think it's a 55 mesh filter, and he has to clean it every week because it gets snails and stuff in it. My filters, I have 200 mesh filters on mine that are built into the valve assemblies. I usually only clean those once a year because I have secondary water that comes in. It's a little cloudy and silty, but it's all really small stuff. So it just goes right through the filters. Question in the back.
So on the pressurized secondary water, they have the filter that's on the main incoming line for the city. I have no idea what mesh that would be at on those.
Right.
But are you saying you need one behind that?
Yeah, so if any filter is provided by the city, and it's honestly very rare to have any filters provided by the city.
Or whoever installed it.
Yeah, or whoever installed it before that. So usually, and on my system, my house, well, up until it broke 2 years in a row until I took it off, I did have like a 55 mesh filter on it to catch any big stuff. And so that won't do anything for drip. That stuff blows right into a drip system and plugs it right up. So you can still have that one on there, and that will help prevent your sprinklers on your lawn from plugging up because they have much larger openings. But then you'll still need to step down to 150 or a 200 for your drip system in order to keep it active. So
On your pop-ups, they have
that little screen, yeah, in the bottom.
Filter.
Yeah, the pop-up.
I've taken mine out because they plug up so often.
Right.
So do you recommend you leave those in?
I recommend you leave those in. So I filter mine, and those screens still plug up. So I know that the filter doesn't catch everything, so I still have to clean those they're the little filters that come underneath the sprinkler heads. Question in the back here.
On my incoming secondary water, my filter is a series of discs that I unscrew. Do you have any idea what the mesh would be on that?
No, the mesh, you would have to look it up by the manufacturer, and on a disc filter like that, it's based on color. So green, yellow, blue, red, by manufacturer, they'll be able to tell you what it's screened for.
All right.
Yep. And do we have any questions online, Casey, that I can field?
Yes, somebody has asked, what about the hard water and mineral deposits?
Yeah, so hard water and mineral deposits can eventually cause drip emitters to plug up. It's not as common as you think, really. That tends to build up more on the outside of the pipe and around the opening. So if it closes the opening over, that's a problem. But most of what plugs up the emitters is just silt from the water line. Any others, Casey? We have one here in the class, a couple here in the classroom.
Yeah, there's one, where can I purchase filters?
Okay, I'll show you some more filters and talk about that in just a minute. We have 2 questions here in the room. So first, yeah, you in the front.
So I'm in American Ford. The city does provide a pre-filter with pressurized irrigation. And then afterwards, I have the filter regulator all in one. And I have multiple of those, and I have to clean the city one at least once or twice a year. And my individual ones, I have to clean them 2, 3, 4 times a year.
Right.
They just have what, and we do get the calcium buildup on the long drips, and it just starts killing the end, and I have to cut it off and replace it.
Yeah, and that's exactly right. So, and I see this a lot too. If when I use the 1/4-inch tubing, which we'll talk about, that plugs up really fast. So with hard water and with stuff inside, and so with those kind of things, yeah, you just have to chop them out and put new pieces of pipe in, because you can't clean most of those emitters. We'll talk about some emitters that you can clean and when to use those, like flag emitters, and there's some other ones as well. Question, yeah.
Yeah, so I know that there's a filter by our main valve, but you're saying that it's good to install yet another filter.
Yeah,
I
and
do not know what mesh it is on the main filter.
usually on a mainline filter like that, it's maybe 50 or 75. It's pretty coarse. It's just to stop things like snails and branch bits and large sand and things like that. Stuff that would be big enough to plug up your sprinklers, which have a much larger opening than a drip.
So my question then is, where would I install another filter? You said to find another one.
I'll show you some options here coming up. Yep. All right, Casey, any others?
That was it.
Okay, next slide. All right, so here's just some other examples of filters. So the filter on the left, the blue one there, that would be a mainline filter. That's a 55 mesh filter. So heavy duty screen, a stainless steel screen. And then there's the other two there, the 155 mesh filter in the middle and the 200 mesh filter on the right, just for comparison purposes. And then the two pictures on the left, those are the housings for the 200 mesh filter on top and the 150 mesh filter on the bottom. And in these cases, they can be installed either in a main line or on a branch line, which is actually better, to where you actually have an individual drip valve that's going out there. So if you've got a valve in your valve box that's hooked to your timer in your garage that is just drip, then it should have a separate valve. And that's where drip filters usually get installed if they're integrated into the system. Is right there. And then I'll talk more about it, and I think you'll understand it when we get there. All right, next slide. All right, pressure regulation, and because I'll come back to filters when we talk about how they're integrated into valve assemblies, and that will make it easier to see where they're added. So I'll go back one slide. So to come back to your question too about that, where you would install these then is you actually have to cut. You have to actually cut your main line or your branch line for your valve is, and install these with some fittings into your PVC pipe.
But you only do it for the drip area, not for the pressure irrigation.
Yeah, for this fine of a mesh. Yeah, because if you did really fine, like a 150 or 200 mesh filter for all of your irrigation system, you can do it, but it's going to plug up a lot just simply because of that large volume that's going through there, say for the lawn. So that's why there's generally a separate one added just for the drip, because it's a lot finer and you're going to have to clean it probably a lot more separately. All right, next slide. So pressure regulation. Most emitter devices on drip systems are designed to work between about 15 and 30 pounds of pressure. Most poly pipe, or the plastic pipe that we use to connect these things, will handle up to about 55 pounds, and then it starts to burst. And emitters tend to put out more water as the pressure increases. Now we'll talk about pressure compensating emitters that don't do this, but the average emitter does increase water leakage a lot more as the pressure goes up. So a 1 gallon emitter at 20 pounds may emit 1.5 gallons per hour at 25 pounds of pressure. So they're very pressure sensitive. And these pressure regulators can be standalone or integrated into other components. So what I'm showing here on the left, these are two that you could buy. The top one is one that you would put into like a system main line or into a drip line if it's in your valve over by where your valve comes out for your drip. And that will regulate everything that comes out of that valve will be regulated to 25 pounds of pressure. And so any drip that you put on that line after that will be pressure regulated to 25 pounds, and so you're good to go for anything you add on that line. The bottom one there, that's like actually a little RV type pressure regulator. It's adjustable, and it's designed for hose fitting. So that's one you could even put on if you're just going to hook up to a hose bib. And there's other options too, and I'll show you those here in a minute. And then the one on the bottom there, that is one that you see on a main line. So that is actually a picture of my pressure regulator on my main line that comes from the city. So I have 100 pounds of pressure that comes from the city, and I regulate it down to 70 for my sprinklers. Now you can go to the next slide. Okay, and then what's really been good now is the manufacturers for quite a few years now have actually built filters and pressure regulators into one piece, into one unit, and that's what's shown in both of these pictures. So that top left picture there is 25 psi. There's a pressure reducer that's built into the line that goes underneath, and then the cap unscrews on the right there, and that's how you access the filter. So it not only filters, but also reduces the pressure. And manufacturers have even taken it one step further in that they sell these as complete assemblies. So they're about $50 for these valves, but you get the valve and the filter with a built-in pressure reducer all in one unit. It's already put together for you. All you got to do is stick it in your valve box. And then you just have to, check those filters every month and see if they need cleaning. So, and they're super durable, lasts a long time. And you can also just replace the filter if it breaks. Sometimes they rupture. And as long as you know the manufacturer, you can take it into a sprinkler store, or even, well, I haven't seen the home centers carry separate filters, just a separate screen that you can buy. But I know places like Sprinkler Supply and Sprinkler World carry some replacement filters, or they can order them in. And so you don't have to dig it up and replace the whole system. You can just replace the screen that goes inside. All right, next slide. Okay, pipe. Let's talk about pipe and tubing. So to really make things confusing, all of the tubing or pipe sizes that are used in drip irrigation from different manufacturers are nominal sizes, which means that they vary somewhat from manufacturer to manufacturer. Even if they say ½ inch on the packaging, they're about ½ inch. Some are a little bigger, some are a little less. Same thing with 3/4. So make sure that you choose the fittings that will fit the nominal pipe sizes you're working with. So staying with the same brand, or ones that are within that same size range. So I've got just at my house, I've got 2 different ½ inch pipes, and I can't use the same fittings on those 2 pipes. I have to use 2 different styles of fittings because there's enough difference in the inside diameter that certain fittings won't stay, and I can't get them to seal off. And the outside diameter is a little bit bigger, and so I can't use certain compression fittings on it. So that's also something. It's kind of like once you pick what you're going to use, try and stay with it, because you're going to build up an inventory of parts that work with it. And they're not as interchangeable as they could be. All right, next slide. So what we're talking about here mostly is poly pipe. It's poly is short for polyethylene pipe. This is a thin wall, flexible pipe. And it accepts holes for micro tubing and fittings really, really well. Because it's soft, it tends to, when a fitting is pushed in and stretches it, it tends to close around the fitting and seal it really well. So it's possible to have lots of fittings installed in this kind of pipe and have like very little, if any, leakage or drippage around those fittings, which is quite remarkable, even at quite a bit higher pressures. So it's UV stabilized. These kind of pipes in landscapes can last up to 30 years. So a huge difference between that soaker hose stuff, which is not UV stabilized, just recycled rubber, tends to break down pretty fast in sunlight. These pipes, even if they're exposed on top, can last for a few decades, and if they're buried under mulch, they may outlive you. So, all right, next slide. So what I just showed you there, that was ½ inch pipe. There's 3/4 inch pipe. There's 1 inch pipe. There's 1/4 inch pipe. This is another version of half-inch pipe. This has inline emitters, or what's just called drip line. And so you can see where there's the little spot in there that looks like it's wrinkled and there's a hole. That's where there's an emitter. And this particular pipe, there's an emitter every 12 inches. And I think on these, I think this is an Agrifem brand. I think they emit 0.9 gallons per hour per emitter. So they'll tell you on the labeling, and that's at like 25 pounds of pressure. So if this is pressure compensating, even if you run it at a lot higher pressures or it goes up and down hills, they generally put out 0.9 gallons an hour through a wide range of pressures. If they're non-pressure compensating, if the pressure is high, sometimes there'll be a little fountain of water that comes out of them. It squirts out really fast. And then where you go up and downhill, you can have a lot of water on the downhill side and not as much water on the uphill side and different things like that. So, but again, whatever pipe you're going to use, whatever styles, make sure the fittings that you use fit the pipe size. And so going to the home centers, you can see where people open the packages to make sure that they fit on that pipe that they're trying to buy. Like, do that kind of stuff. Otherwise, you're going to be doing a lot of returns. So find an open package and see if it works, or make sure that the brand matches up. That's usually a pretty good indicator as well. So next slide. Drip tape is a variation on this. This is actually kind of the first inline drip pipe was called drip tape. It's extremely thin wall. It's really popular in commercial ag. It's only designed to be used for 1 year, and then it's recycled. And it's usually laid down with machines that lay black plastic down on the rows, and this is laid down under the black plastic with a tractor all in one push. So you can get it from online stores and some agricultural stores, and it takes, again, its own type of fitting. None of the fittings for that thicker wall punch pipe that we just talked about will work on this. Completely different pipe diameters now, much thinner. This is almost like paper thin stuff. So even if you try to use it another year, it usually breaks down really fast and tears really easily. So, but it's out there, and these typically have really, really low flow rates. So for 100 feet of this kind of pipe, this drip tape, it might emit 1 gallon per hour for all 100 feet. Very, very, very low output rates for those. So they really are kind of, you leave it on all day or even a couple of days to get the water that you need. Next slide. Header pipe is just using some of that pipe to connect emitters or other irrigation tubing, usually when making a grid system like what's shown here, where you have pipes laid every like 6 inches in this case. So then we might call that a header pipe, but it's actually just mainline or distribution tubing that has just been divided into really small sections. We'll talk more about making a grid system towards the end. All right, next slide. All right, distribution and mainline tubing. These connect to the water source. They can be a straight pipe run, or they can have emitters attached to it along the way, or micro tubing attached along its length, like the picture on the bottom. So the picture on the top there, that's a drip irrigation system that's watering some grapes in a research project that I have. And it basically, that pipe attaches directly to the water source. It runs down the line of the grapes, and there's emitters punched directly into it that just drop it right on the ground below the pipe. So it doesn't distribute the water anywhere else. And then this picture here is a different area that shows the distribution pipe that's run off that main line, those 1/4 inch tubes that take it out to emitters that water each individual plant that's there. So micro tubing, which is that 1/4 inch tubing that you see on the bottom, can also be used as distribution tubing, but you run into problems with this 1/4 inch tubing because it doesn't flow very much water. You can only run the micro tubing about 30 feet before you have enough pressure loss that it's not very usable for irrigation anymore. Question here in the room? Yeah, yes.
That bottom picture, is that what you would recommend to do kind of a big area of flowers versus the spray that you said is not a drip?
Yeah, so that's a good question. And I will talk about what I call a grid system for drip, and that's what I recommend if you're going to be using flower beds, especially if it's annual flowers where you're going to be planting stuff in and out. You don't want to mess with distribution tubing and little stakes to hold them in place. That's a nightmare.
What if it's both perennial and annual? So that you get.
Yeah, then a grid system will actually cover the whole thing 100%. So I'm a huge fan of the grid drip systems. Like I would never do anything else in my yard, and that's what I've converted my yard over to. All right, next question, or next slide. So micro tubing is this little black stuff here, these small tubes, 1/4 inch in diameter. There's also 1/8 inch micro tubing available, but it's less popular in landscapes. We see it sometimes in ag. We used to see it a lot in greenhouse and controlled climate kind of irrigation systems. It's made out of polyethylene or vinyl. The vinyl is softer and a little easier to work with, but it expands a lot in the sun. So the expansion and contraction is pretty extreme, and it's more likely to come off of its fittings. It can work its way off of the fittings. So you can find it in a lot of places. In most of the stores I've seen that offer vinyl tubing, they also offer polyethylene tubing, and I like the polyethylene tubing. It actually lasts longer as well. This kind of tubing is used for point source or spot watering, and if we go back a slide, can you go back one slide? This micro tubing in the lower right picture, the lower picture there, is polyethylene, just micro tubing, and it doesn't have emitters built into it. It's just got an emitter at the end, or it's dripping water out at the end of the pipe, right at the base of the plant.
Only at the base.
Only at the base in this case, yep.
Okay.
And that's what I'm calling point source. So you have one point that's the source of the water for that plant. It's not emitting any water along the length of that pipe. It's only at the end.
Okay.
All right, we can go, I think, 2 slides. Casey, do we have any questions online?
Yes, we do. Just have to go back to where they were. Okay. So somebody said that they had a zone with 6 heads, converted 3 of the heads to drip, and capped the other 3. 2 of the caps blew off when she turned the water back on. Her question is, will the pressure eventually cause leaks, or is there something better than caps? And there were some follow-up questions from others.
So to answer that question real quick is they need a pressure regulator on that line.
Yeah,
It's
and that's
gonna
what
keep blowing stuff.
she put it on the 3 that she capped, but not the entire zone.
Yeah,
So
you can put it on the entire zone would be better, but it's probably going to still keep blowing caps. And also too, city water supplies vary in pressure. They can spike it much higher than what you might measure it at, like at one moment in time. Like I measure 100 pounds, but I know that it spiked higher than that, and sometimes it drops lower than that when other people are irrigating on the street. So, next question, Casey.
just somebody requests, is the QR code going to be at the end of this again?
I'll put the
you show it
QR
at the
code I
end?
have at the end is for the survey, but I'll put it up for you.
Okay.
All right, there's also soaker hose micro tubing, again, coming back to that. That's what's pictured here. That's 1/4 inch micro tubing. That's that soaker hose or the dew hose, and it will fit on the fittings that we use for this polyethylene or vinyl tubing. And then there's the inline emitter style, and that's what you see here in the 1/4 inch stuff. This is on my raised bed at home, and I set that up on a grid. So that grid system is like, if you want to do vegetable gardening, it's the only way to go. Because we plant peas, we take the peas out, we can put the carrots in, whatever, and we don't have to change the irrigation system at all. Anything we put in that bed is going to get water. Question?
Is that inline emitter, does that get clogged?
Yeah,
Yeah.
yeah, they
So it
get
has to
clogged up.
Stay above the,
Oh, it doesn't have to stay above the dirt. You can bury these. They don't tend to get clogged up with dirt. They tend to get clogged up with dirt on the inside from the water.
okay.
Yeah, no, they'll leak water out of the dirt doesn't plug the hole.
Working in the dirt and
No
getting
problem.
dirt on the outside of that is not going to.
Not a problem, because there's enough pressure in those to push the dirt that does get into that opening out
But it's
generally
the
pretty well.
inside.
It's the inside. or hard water that gradually closes over the hole.
So you have to replace it every so often.
Yeah, now I've had pretty good luck with this one. I've had it in for, I think, 3 years now, and it's been fine. But in my landscape, I have a different type of this 1/4 inch tubing, and I have to replace that in sections pretty regularly. So, question, yeah.
It comes in 6-inch and 12-inch. Which one?
We'll talk about that. Yeah, we'll talk about spacing and what's recommended here in just a little bit. So, all right, next slide. The poly pipe is also going to have to be secured. So there are different kinds of stakes that are made for it. These shepherd's hook stakes are really popular. You can find those at the home centers. What you find at the professional sprinkler stores, though, are landscape staples, which hold the pipe a lot better. So I always opt for a package of 100 landscape staples because it's two full tangs that go down into the ground instead of just one. They also tend to get pretty rusty, and after about a year, it's hard to pull them out of the ground because they get rusty and then they really integrate with the soil in there. And so they may or may not last very long. But the pipe has a tendency to work up to the top, and that's shown here in this picture. You can see that originally when this landscape was installed, all of that irrigation tubing was buried under the mulch. But through heating and cooling throughout the day, it gradually works its way to the top. And that's unavoidable. It will happen. And the only way to fix it is to rake all the mulch out, stake it back down, stretch it back out the way it used to be, and put the mulch back on it and try and keep the mulch 3 inches thick on it. And so that is one big drawback to drip, is that you're almost always going to have stuff sticking up out of the ground and potentially tripping on it and it not looking super clean. That's always the trade-off here. Next slide. Securing micro tubing, you can use the same shepherd's hook stakes or whatever you used for the mainline tubing, but there's lots of little specialty stakes that will hold the little micro tubing if you're running those distribution lines down to an individual plant. So plastic stakes that in some way or another allow the tubing to snap into the stake. Now the picture in the middle, that's actually an emitter. That's a 1 gallon per hour emitter at the top with the plastic stake all built onto it as one unit. So you stick it in the ground, hook the tubing up to it, and you're good to go. There's no separate piece that you have to buy. So again, lots and lots of options out there. You just kind of got to wade through it and see what will work best for you. Next slide. Closing the ends. This is really important because if you don't do this, you'll never get much water to come out of your drippers if the pipe doesn't pressurize. What most landscapers do and what I do in my yard is I just kink the hose and slide another piece of pipe over it. So it doesn't cost very much money to do this, but it is a little unsightly, especially if you don't have brown pipe to do this with. But they do make a figure 8, and that's shown in the bottom picture on that brown pipe. It's basically just a piece of plastic with two openings in it, and it just slides over, and then they're easy to slide back and unkink the pipe to flush it out. And I open them up when I blow my system out at the end of the year. I do have a lot of figure 8s on mine as well. And then I slide open that up, blow the water out, and then close it back up so the spiders and stuff don't move into the pipe over the winter. There's other ways to close pipe, though. The picture in the middle there is just fitting that can be pressed on the pipe, and it has a cap that you just screw and unscrew. In my opinion, though, it's like, well, you can fold it over and you can get a pack of these figure 8s. You can get a whole pack of those figure 8s for probably what one of those cap fittings costs, So there's just lots of different ways to go about it. It just depends on how many fittings you want to buy and how big your budget is. And then the bottom picture on the right there, that is an automatic draining end closer. And so that is that when the pipe pressurizes, it actually pushes a little flap at the end closed, and the pipe will pressurize. And then when the system shuts off and the water pressure drops in the pipe, the little flapper at the end opens up and it drains all the water out of the pipe. And so those can be good if you're worried about things freezing overwintering. It just automatically drains those out. So I personally don't like them because every time I irrigate, then I have to refill the pipe with water, and that can be a few hundred gallons depending on how long of a pipe you're running and how big it is. So potentially a lot of water that just gets dumped out into the landscape that's not going to really necessarily be useful. Question, yeah.
So leaving this in your garden, over the winter, you have concerns that there's water in it, will split it?
Yeah, so that's a good question. And, you know, what do we do in the winter? So these pipes are very resilient with water freezing inside because they're very stretchy. What isn't resilient are the fittings. They're a hard plastic. And so if you don't blow these out or drain them, then you do have a chance of rupturing the fittings during the winter. So I blow it out. I blow all mine out with air. So even if you have automatic drains, I would still blow it out with compressed air, because there's always low spots in areas that won't get drained. Question?
I've been using drip in my yard 30 years. I've never had one freeze.
Yeah. Yeah, and I've seen a lot of people that do it, but I have seen where the fittings, the elbows and stuff do freeze, and then you have to go and cut it and all that. So, but the pipe itself is super forgiving. So if you don't have a lot of fittings, and especially along the inline pipe, if you have a lot of inline emitters, those will just kind of gradually leak the water out of the pipe, and so they kind of self-drain on their own anyway. I don't find that happens as well if you punch the emitters in. Those emitters don't drain quite as well. In fact, a lot of them are designed to only open up when the pipe is pressurized, so they will hold water in the pipe. So, next slide. So there's other fittings too. I'll just show a few examples of those. Just again, make sure you pay attention to the fitting sizes that they work with your pipe. And pretty much all these fittings are reusable if you can get the pipe off of it or out of it. And that sometimes is a real challenge. All right, next slide. Okay, so here's some fittings here, insert and barb fittings, and the terms kind of gray together a little bit, if you will, because they all have barbs on them. Both styles are insert fittings, but technically an insert fitting needs to have external clamps, and that's like the one on the top. So you can see that gray insert fitting on the top has barbs on it, but they're not big enough, sharp enough barbs that they will keep the fitting or the pipe from being pushed off the fitting. And so that's where the clamps come in. The fittings at the bottom are true barb fittings, and you can see that the barbs on those are much bigger than the pipe fitting up above, and they're sharper, and they also have one barb that's larger than the others that really grabs the pipe. And so with the brown one and those two black ones on the bottom, those are both half-inch fittings there. They don't need clamps. The pipe pushes on there, and you don't have to worry about clamps. The gray one at the top, that's a 3/4 inch insert fitting that is more of a commercial type of application. Question?
Is there a trick to getting the pipe onto those barbs, or is it just strictly muscle?
Brute strength.
Okay.
So there's one major trick, and that's heating the pipe up. So either you have a little bucket of hot water that you put the end of the pipe in for a few seconds and then push the fitting on, or drag a heat gun or a propane torch out there. But this stuff's flammable, so you can melt it. You get a little blowtorch going and have a little thing in your yard that's on fire if you're not careful. So I prefer the hot water. But sometimes I just leave the pipe laying out in the sun for a little while, and that usually does the trick too. I have done a lot of systems in greenhouses using the 3/4 inch insert fittings. And strangely enough, I end up doing most of this work in greenhouses in the winter. And the pipe is cold and it doesn't fit onto those fittings very, very well. And I've actually torn the ligaments in my arms trying to push them together. So I actually bought a $300 tool that you can clamp the pipe and the fitting into it and use a cordless drill to actually compress them together. And then my kids can do it. They can help me out. So you can get specialty tools that are designed for stuff like this, but if you heat the end of the pipe up, it usually does the trick. Yeah. And then the other thing you need to be aware of, and I see this mistake a lot, is people don't push the pipe on far enough. They think it's okay to just cover the first or second barb. It isn't. The pipe has to go all the way on until it stops or basically hits the corner of those elbows or the T's. And that way, because when it does pressurize, it will actually back off a little bit as the barb, so that the barb can bite into it. And if it's not all the way on and it pushes back, then it tends to just rupture, or the fitting comes out of the pipe. So it is important to make sure you get those all the way on the fitting. Next slide. Here's just some other examples of barb fittings. And I put the picture on the right that's how you remove the fittings from this kind of pipe. That's how you remove a barb fitting from a pipe or an insert fitting at all, is you have to slit the pipe. So I usually just take the pipe cutters, the scissor ones, and just open them up and just cut along that fitting. It does damage the fitting underneath it, put a cut in it or a little scratch in it. Usually it doesn't leak there, but if it leaks, it's usually no big deal because we're leaking a little bit of water out of this pipe anyway. So, but if you're willing to do that, you can reuse the fittings, and the fittings are by far the most expensive part of all of this, and the emitters. But the pipe is cheap. I mean, it's like the least cost of all of this is the pipe. All right, next slide. Compression fittings, there's a couple main styles of those. This is an insert style compression fitting. It's like a one-way handcuff. So instead of the barb being on the inside like we just saw, the barb is on the outside of the pipe. So you push the barb in and there's a kind of a sharp collar on the outside that when the pipe is inserted, it grabs onto it and the pipe can't back out. These are quite difficult to install, and heating the pipe up will actually hurt you in this case. You'll want to actually cool the pipe down and try and shrink it so that it fits into the collar easier. So the pipe's forced into a smaller diameter collar or compressed, then it can't back out. It's very difficult to remove pipe from these fittings. It usually involves a pair of needle nose pliers and a lot of brute strength and a bench vise to get it out.
So if I have to take one out, I just cut it and give it a half-inch ground with the needle nose.
Yep. If you can get it to deform and fold in on itself, then they'll come out. But it does take going in there with needle nose pliers, twisting it, and kind of ripping it out of there. So they're quite difficult to get out. You can't just slit the pipe and have it slide out of there. And then there's a stop on the inside that the pipe is supposed to go into. The stop usually goes in all the way to where the next part of the fitting stops. So usually about an inch or so in there to make sure that it grabs the pipe. All right, next slide. Then there's compression fittings. This Permalock style fitting where the pipe is pushed onto a small barb fitting or another reinforcing piece on the inside. And then there's this external collar that screws down and holds it so it can't back off of that barb. So, and these are nice. The one on the bottom, this one with the brown collars on it that's on the bottom is actually designed for multiple pipe sizes. It fits a range of half-inch pipe. Just by the way that it's designed, it can seal off slightly different variants of half-inch pipe. And I tried to show that here. I've got my half-inch black pipe on coming out the top and the half-inch brown pipe coming out the other side. And they're both half-inch, but from different manufacturers, they're not exactly the same half-inch. But this is more of a universal fitting, and it can work with those. Next slide. Micro tubing fittings. These are all barb fittings that are inserted into the poly pipe with the right size hole punched in it. Like I said, it's usually an 1/8 inch hole. It's better to punch these holes and not drill. If you drill a hole, it leaves a jagged edge and they leak like crazy. So if you want a nice clean hole, you just use a punch. And you'll hear them snap in. Where we run into problems getting these to snap in is when the pipe is really warm. It just stretches and they don't snap in all the way. So sometimes when you think they're all in, you go turn the water on, you hear all these and the little pipes are blowing out. You have these little fountains out there. A lot of times if I'm doing this in the sun, I'll actually turn the water on and run water in the pipe to cool the pipe down and then put these fittings in so that I know that they're snapping in all the way. And sometimes if the pipe is really warm, you won't get the punch to actually punch all the way through it. It'll just stretch it on the inside. So sometimes running water in the pipe to cool it down will help that so you can get the punch and these fittings installed into it. And then again, just make sure the micro tubing's pushed all the way onto the shoulder or the stop so it goes well past where those barbs are, or it will back off as well. Yeah, question.
Put your punch a hole and then later on decide.
We'll get there.
Oh,
Yeah,
okay.
yep. A goof or a mistake. Yep. See, right here.
There it is.
Goof plugs. So these are designed to plug those mistake holes, or you're moving a dripper. So you don't have to replace a section of pipe. It's basically just the barb portion with no hole in it. So you snap it in. They generally do a pretty good job of sealing, but where we run into problems with these sealing the hole is how you remove the fitting that was there before. Did you tear it out with a pair of pliers and now it's this jagged oval? Or is it a nice straight pull where you pulled it out nice and straight and it didn't damage the hole? Does that make sense? So
Yeah.
they work pretty good if you don't rip the hole wide open when you're taking the old fitting out. So, and the old fittings come out, you basically grab them with a pair of pliers and just pull them out. So there are some tools, like I showed you that Rainbird tool, that will remove certain types of emitters and things. But for most intents and purposes, you're going to be pulling these out with pliers. Next slide. All right, and then insects can get in the microtubing, get into the emitters and plug them up. And so they do make these what are called bug guards or bug shields, and they're usually sold separately. And they just push onto the end and the friction fit. And then I just took a picture of the end of it so you can kind of see it's mostly closed with just little openings around the edge, not big enough for an insect to get in there that would plug it up, but for the water to still come back out. So I actually don't use these, and I've not had much of a problem here. Maybe in other parts of the world it is a bigger problem. All right, drip emitters. Remember, we're not discussing microspray. Next slide. All right, so I talked about pressure compensating emitters. They will output. So these are 1 gallon per hour emitters. And typically, if you look at the output curve over a range of pressures, they vary only maybe a few hundredths of a gallon per hour over something like 15 to 40 pounds of pressure, or even 50 pounds of pressure. So they hold that water flow very, very nicely. The emitter opens when the water pressure is low. So at the end of a line or down, up a hill or something like that. And the emitter opening is pushed closed more when the pressure is high. So if you have high pressure points on the line and low pressure points on the line, those emitters tend to put out the same amount of water. They're remarkably good at this. And the first ones that I ever encountered, and I searched 20 plus years ago when I first got into this, Chapin Watermatics pioneered this whole idea of pressure compensating. So, it was a game changer for the industry. Question?
I don't know if they've improved them, but my experience is they just plug up so fast and have to throw them away.
They have improved them. I have used a lot for a long time, and the only thing that I've ever had problems with them plugging up is when I've had algae growing on the inside of the pipe and coming off. So, and it's largely because a lot of these now are what they call turbulent flow emitters, which basically the water goes through actually moving and churning instead of this very lazy, slow flow that's going through this little maze of tubing. And those do a much, much better job at keeping the debris from settling inside the openings. But there's no visible way to determine if emitters are pressure compensating or not. So like I just put a picture of the bag here. Again, not any one brand. I just wanted to go and see what was available and get something that you could find. But it says right there that PC emitter. If it says PC emitter is pressure compensating, they usually cost a little bit more. In my experience, especially if you have long runs or hills, these are the way to go. Like they're really great. And you can also get inline emitters that are pressure compensating as well. In fact, I'll show you. Okay, next slide. Here's some other examples of pressure compensating emitters. This is an old style emitter here. This was one of the first pressure compensating emitters that Chapin Watermatics came out with about 25, 30 years ago. And those are the ones I did have problems with those plugging up. But they're somewhat cleanable. The picture of the dripper in use there on the pipe, and then the picture where I've taken one apart, that's an emitter that I bought specifically. It's a pressure compensating emitter that you can take apart and clean. And I use this on secondary water in some of my grape, all of my grape research trial actually. I just switched over to this because where my grape research trial is at Thanksgiving Point, it's on slopes. And we had very big differences in water output in different parts of the slope. So I went to all pressure compensating emitters to make sure that all the plants were getting the same amount of water. So they'll just say on the bag. Sometimes there'll be little indications on the side, like it might say PC or something molded onto the side. That's pretty rare. But if you take them apart or you see some little disc or rubber element inside, that's a good indication that it's probably pressure compensating. Question?
The number on the corner of that bag,
The 30?
yes.
That's for Home Depot. So that just basically says that you need to use this. I think it's matched up with item 30 on the shelf. Does that make sense? So they're
I was wondering if it was a maximum or minimum.
no. So, but if you look, I don't know if you can read it very well. They're 1 gallon per hour emitters. So, and that's usually indicated by the color. Black is not industry standard, but most manufacturers have adopted black as a 1 gallon per hour emitter and red as a 2 gallon per hour emitter. But again, there's no worldwide standard for that. Manufacturers are free to choose whatever they want. You can sometimes see blue as a 2 gallon per hour or blue as a 1 gallon per hour. Like I have some flag emitters that are blue, they're 1 gallon per hour. So it just depends on what the manufacturer decides they want to do. Next slide. Here's flag emitters. These are great. I've seen these locally. These I bought for an agricultural use. The flag makes them easy to see, and they're easily removed. As long as you line up the little tab on the side and pull it out, you can clean the little opening. So the water has to work its way around that screw and then leak out the side, and that's what slows the flow down, is the water has to work its way around that little screw in there. So these are great because they can be taken apart and cleaned, but they're not pressure compensating. They don't have a pressure compensating rubber flapper in them. Question?
The nice thing on these is most of them have the gallon per hour on the tab written on.
Yeah, they're pretty easy to identify because they have a lot of plastic to identify the gallons per hour and things like that. Yep. All right, next slide. And inline emitters, again, they're integrated into the pipe during manufacture. A lot of the styles that they make now are self-cleaning, which means that they do have an active flapping motion inside that helps keep debris from settling in there. But you do have to replace pipe sections when they plug up. And like I said, I've had a lot more problem with the 1/4-inch tubing plugging up than the 1/2-inch tubing plugging up. And they're available in several spacing options. Typically what you can find is 6, 12, 18, and 24. The 6-inch spacing is usually only available in the 1/4-inch tubing, but you can special order it in the 1/2-inch tubing. And then you've got drip tape as well. So next slide. And then just some other emitter styles here from other manufacturers. This is some Amazon stuff on the right. And again, this particular brand, Dig, I've seen at various home centers in Utah Valley, and it's just commonly carried. So, but they don't say anything. And if you didn't know it was pressure compensating or not, like on that button dripper, it's not pressure compensating. There's a wide flow passage that resists clogging. Of course, there's always marketing material on there. But notice also 1 gallon per hour. You'll see that that's a common theme with me. We'll come back to that here in just a minute. Okay, next slide. There's also flow control options, valves, inline valves. You can see the one at the top, that's just a barb fitting that's a valve. I don't see much use for these on main lines, like where those are installed, but I do see some use for them where I have containers and hanging baskets on my patio. If I remove a plant, like I had some containers that didn't make it through the winter, and I didn't put new ones out there this year, so if I have these little things, I can actually shut the water off to that little dripper, and the plant next to it's fine, but I don't have that water just getting all over my patio. So there's lots of options there, these little inline micro valves and stuff. Again, how much do you want to spend and how much control do you want? There's options out there to do about anything you want. Next slide. Next slide. So to connect to a water source, if you're just adding a system on, then you might just be using a hose bib. So basically what you're looking for is a hose bib adapter. So something that has the end on it that will fit onto your hose bib that comes out of the wall or out of the standpipe in your yard, and the other end connects to some sort of polyethylene or plastic tubing. So there's two different pictures here. The one on the left is just simply a conversion or fitting that takes us from the hose to the drip pipe. And then on the one on the right, I've added a pressure regulator that is a hose fitting. So it's a 25-pound pressure regulator, that fitting at the top, and then it goes into the hose fitting for the polyethylene. So everything that I attach then off of that hose is 25 pounds of pressure regulated. Question?
So what's that white stuff in between the red and the black?
The white stuff.
It's just the valve.
Oh, that's just a hard water on my hose bib, I think.
Oh. It's just balls.
Yeah, just deposits. It's the black. It's just the pure black stuff that I think is what you're talking about.
The white's just the hose bib.
The white's just the hose bib. So, are you talking about like this part right here?
Yes.
That's the faucet. So this is the metal part of the faucet. It's just covered with hard water minerals because it's Utah. All right. So if I unhook this, I put my hose back on it. I just unscrew that black ring right there, and my hose will fit back on that. All right. Other options here, just different ones for different. Here's an insert fitting or a compression fitting and with a hose bib on it. And a lot of these little hose bib connections will come with a screen in there, which is kind of silly for drip because it's not fine enough to keep anything from hurting your drip. And then there's also filters that you can get on this assembly as well. You can get pressure reducing filters, coming off of the house water. So there's, again, lots of options. I'm just putting some ideas out there. The next slide. And then converting from existing sprinklers. I know a lot of people do this. They've got a front lawn that they never use, and they're going to convert it into a flower bed, and they're going to do drip. So there's lots of options, and they basically all center around using the connection that the existing sprinkler had used, which is usually a 1/2 inch, what looks like polyethylene pipe. But it isn't. It's called funny pipe, and it's way too thick to punch holes in, and it's not very easy to work with. But it does have a fitting on it in most cases that allows us to hook up drip tubing to, if you get the right adapter kit. So shown here in the picture here, the Rainbird makes this one. It actually looks like a sprinkler head, but it isn't. It actually just screws into where the old sprinkler was. It screws under the same fitting at the end, and then the top has that fitting on it that lets you put the drip pipe right on it. So this looks like a sprinkler that's been adapted to it. Then you can bury all that in mulch, and you don't have to rip out all of that other mainline tubing underground. Question?
I have 6 of these.
Yeah, and they work good. They work forever. They don't pop up. They don't do anything. They just provide that interface.
And it just converts the entire circuit to drip.
Yeah, everything.
No more sprinkler.
Exactly. No more sprinkler heads here. And that's what I think, that's where people run into trouble is when they might have 6 or 8 sprinklers on their lawn, and they take 2 out and put them in drip, and then they leave the rest on as sprinklers. So the drip comes on when the sprinklers come on. That's a big no-no, because again, now they're not talking the same language and output. Those sprinkler heads are going to put out water at 15 times the rate or whatever than your drip system is. And so the drip system tends to be underwatered. And if you try to water it enough for the drip, then you're flooding the rest of the lawn. So you're going to need to work in whole zones. Take out that whole zone of sprinklers and convert it to drip, not just 1 or 2 heads. Next slide. And there are thousands of different ways you can go about converting this. So you can take existing pipes that you have or put pipes onto where the sprinkler head was, and you can put on these octopus looking things and attach your microtubing to that. It's baffling how many options there are. And again, they can work okay, but you're limited to how many plants you can water and all that with these kind of things. Just make sure that if you're converting from an existing sprinkler that you do the whole zone. All right, next slide. All right, and then to come back to this is the built-in irrigation valves. So these are irrigation valves that are designed for drip systems. They have a filter, they have a pressure reducer in them. And the good ones are also what they call low flow valves, which means they'll open even if you only have 2 or 3 or 4 emitters on the line, like for some hanging baskets. The valves will open with incredibly small flow rates. So they're a bit more expensive, but they're worth the money if you only have a few drip areas that you're using. All right, next slide. So we're kind of getting to the end here and to some of the nitty gritty stuff here. And this is, okay, well, how far can I go with this pipe? How long is the run? This is where I get a lot of questions. These pipes will run out of water if there's too many emitters. There's too many leaks. Eventually, there's not going to be enough for the pipe to pressurize enough and push the water out of the emitters, or the emitters at the end won't get any water coming out of them. So the soaker hoses and the inline emitters especially. So this is the labeling off of some 1/4-inch inline tubing with the 6-inch spacing. And so if you look at the top there, so this came off of a roll of tubing that was 6-inch emitter spacing. And it says right there, maximum length of run at 15 pounds with 6-inch spacing is 19 feet. So that's not very far, right? With this 1/4-inch tubing, just can't handle very much water. But we can up the pressure and go a little bit farther than that. What I do with mine in my grow beds, I have the 6-inch spacing in my raised beds, and I actually pressurize the tubing for both ends. So I can go 40 feet and still get enough water in the pipe. So that's totally acceptable. So just keep that in mind. Look at these labelings and just understand that they'll only go so far before they run out of water. Next slide. Question? Yeah.
On that last slide where it says minimum operated pressure of 30 PSI.
That says a maximum of 30.
Oh.
Yeah. Yeah. Once you get over that, it just blows them off the little micro fittings. Yeah. So but you need about 15 pounds to run it appropriately, and over 30, you're going to probably start blowing it up. And so determine your delivery capacity, which is basically what we started talking about with that previous slide. Consider all the water loss, or add up the water loss of all the emitters that you have on that line, and make sure the water supply can provide at least that much water. The inline emitter pipe can easily run too long for water supply. So looking at this here, this is a 18-inch spacing on an inline emitter. This was at Home Depot. It's a 100-foot roll, and it's pressure compensating drippers that are into this, so it's a really nice pipe. But it says on their maximum recommended lateral length at 25 pounds is 273 feet. So the 1/2-inch tubing can go a lot farther than the 1/4-inch tubing. It's several magnitudes more in how much water delivery can happen in a 1/2-inch pipe. And we might think, well, gosh, 273 feet is not very much pipe. But if you run a length down your yard and back and down and back, all off of one supply line, you're going to run out of water pretty quick. So just keep that in mind if you're looping it and coming back and looping it back down, going around trees and stuff. It's not too hard, but essentially it's 3 rolls of that off of one supply, like 1/2-inch supply at 25 pounds.
That's why you do the header.
That's why I do the header, exactly. Or I'll have several stands for plugging this into that come off of a 1-inch pipe underground. So I might be able to run 1,000 feet or 2,000 feet of that off of a 1-inch pipe. Now, yeah, if you've got manifolds and if you've integrated that, yeah, it's really easy to add a lot of pipe. Now this is 18-inch spacing. If we go to a 12-inch spacing, which you would need for sandy soil, the 18-inch spacing is fine for loamy and clay soil, but not for sandy soil. If you have sandy soil on 18-inch spacing, you're going to have these wet spots, and your plants aren't going to do very good because the water doesn't spread out very well from wet spot to wet spot. So if we go to 12-inch spacing, it's going to change how much of we can run by about 33%. Does that make sense? Because now we're spacing them 33% closer than there's a third closer than at 18 inches. So we're gonna have to shorten our runs by a third in order to be able to fill them up with enough water. So just understand what the label's saying and how much length you're running, or you'll run out of water. Question?
I was just wondering, Dr. Froman, I came here because I was thinking about getting rid of our lawn and going into some kind of.
Right.
But it looks like you're talking about watering huge areas from underground.
No, this stuff just lays on top.
Okay.
I wouldn't bury this. Yeah.
How much more efficient is a drip irrigation system, or should I say, what's the conservancy rate compared to just like watering along with sprinklers? Or?
So like I said at the beginning, watering a lawn with sprinklers, the typical irrigation system on a home lawn is about 70% efficient at distributing the water evenly. So everybody always has these brown spots, right? And those are there usually because the sprinklers don't spray exactly right in that area.
I guess what I'm asking isn't how well it covers, and maybe you're getting to that, but how much less water it takes with your
Yeah.
losing it through evaporation as much.
Yeah, well, but what I'm saying with distribution uniformity is actually a big part of what you're asking.
Okay.
Because if the water is distributed across the landscape more evenly, you will use less water because you don't have dry spots that you're trying to water extra. Does that make sense? And that's where most people have their water loss issues in their lawns, is they see a brown spot, so they increase the runtime by 30%. Well, the rest of the lawn, like you got to have a canoe to get out there, right? And you're barely keeping the dry spot green. So, but the distribution uniformity of this is like 90 to 95%, which is huge. I mean, that's as good as a Mother Nature rainstorm. A rainstorm is typically only about 90% efficient in distribution of water. So they're excellent if you install them right. So, and you can do huge areas with them, certainly. Yep. Next slide. All right, so just another chart on run length. Typically, a 1/4 inch pipe, and I think this is at 15 pounds of pressure. 1/4 inch pipe can run about 30 feet, a 1/2 inch pipe about 200, 3/4 inch pipe about 480, and a 1 inch pipe about almost 1,000 feet. So just keep that in mind there. That's just how much water those pipes can deliver. And again, the notes I'll put the notes online. Sorry I didn't have them ready before class. I thought I did, but next slide. All right, so this is where I wanted to end this, and we've got no time to talk about it, but this was probably like the most important section of the whole thing, and it just took us an hour and a half to get here. So if you got 5 minutes, stick with me. And this is figuring out how long to water your drip system, and almost everybody gets this wrong. Until I learn this, I know I'm irrigating wrong with my drip. So irrigation needs are usually given in inches of water. So if you go to USU's website, or the Water Conservation District's website, that might say, well, during this part of the summer, we might need to water 2 inches of water a week. Great. How the heck does that have anything to do with drip, right? We're talking about inches of water, and we're talking about these things emitting gallons of water per hour. So how do we make that translation happen, right? So next slide. There's 3 main ways to do this. One of it is to go out and measure it with cups, like underneath your drippers, which is a mess. The second way is to estimate it using manufacturer's charts like this. So this is off of a Netafim brochure, but they stick this on the rolls of pipe as well. And so it basically says application rate in inches per hour right here at different spacings of their emitters, right? So that's a good way to know that. So when you get up in here, you have a lot of the emitters that they sell here are 0.9 gallons per hour. So you can see that if you have a 12-inch spacing at 0.9 gallons an hour, you're going to put down an inch and a half to an inch and a tenth in an hour. That's way more than most people realize they're putting down. How long do most people leave their drip systems on? 2 hours. They're in a lot of cases, they could be putting on as much as 4 inches of water in 2 hours. We would never say for anybody to do that on their lawn. So why are people doing it with their drip systems? It's because we don't understand how to convert that tiny flow rate into inches per hour, but they put out a lot of water per square foot compared to sprinklers. Or we can calculate it with some basic information. Next slide. So there's a basic formula here, and this will work for whether you've got point source or inline emitters in a basic way. We have this 231, which is a constant, and I mentioned how we get that constant. It has to do with how many gallons are in a cubic foot of water and so on. It's a whole other separate calculation to get that. So we just put that in there for you. So that 231 times the emitter flow rate. So if we have a 1 gallon per hour emitter, that would just be a 1 there. And then divided by the emitter spacing in inches, multiplied by the line spacing in inches, or how far apart the emitters are from each other, and that will give us inches per hour. So if we look at an example over here, if we have 1 gallon per hour emitters with a 12-inch line spacing, that means that we have lines running in a grid and they're 12 inches apart, and the emitters in each line are 12 inches apart. Then we get this 231 divided by 144, and that equals 1.6 inches an hour. So if you have a grid system set up in your yard like I do, and your grid's set up about every 12 inches with 12-inch emitter spacing, and I run it for an hour, I'm putting on a week's worth of water in an hour. And most people will run their drip systems for an hour and a half to 3 hours, and it's way too much water. Question?
So it sounds like if you have 1.6, if you want to get 1 inch and it was going to get that in an hour, you should just run for 20 minutes, 3 days a week.
Yeah, so what we do, if we're putting out 1.6 inches per hour and we only want to put down an inch, then we'll run it for something less than an hour. It'd be something like about 40 minutes.
Yeah, it was just,
Right.
if you had 1 hour, you divide it up into several days, right?
Yes. So we might say in July, a lawn in Utah, say, or a flower bed in Utah needs 2 inches of water a week. We won't put all 2 inches on all at once. We might break it up into 3 different, like every other day. So we might put on a half an inch of water, say, or 2/3 of an inch of water, Tuesdays, Thursdays, and Sundays. And so knowing that, then you might only then run that drip system for, say, 30 minutes or 40 minutes to each of those days to get that much water, not like an hour and a half or 2 hours each of those days. Question? Yeah.
The grid system, is that just one line down?
I'll show you. Next slide. Will you go to the next slide for me? And the next one. And the next one. All right, and the next one. Okay, and the next one. All right, okay, grid drip. So this is a grid.
Okay.
So basically where we have, now this is using inline emitters where they're built into the pipe, but you can buy blank pipe and just put your own emitters in. It doesn't matter how the emitters are installed.
Do you ever buy that kind of pipe and then poke a hole in it for
Sure.
a special one?
Yeah,
Okay.
yeah, sure. Yeah, you can punch holes in this stuff, no problem. So you can run emitters out there. Just remember that all of those are going to count towards the total flow. You know, how much can that pipe handle? If you're going to add extra ones to it, then you're not going to be able to run it as far. Does that make sense? So you're going to be taking water out of it, so you got to make sure that you're keeping that in mind. But yeah, just a basic grid system like this. And so in these kind of beds then, as long as the plants that you plant are fairly near where those lines are, then they're going to get water. So you can change plants out. All the drip in my yard is a grid system. So I can add plants, take them away. My yard's an experiment. Like I tear stuff out and put new stuff in all the time because I do it for a job. It's just what I do. And so point source was a nightmare for me, like running those little string lines out and, putting the stake in there and holding it there. And then the neighbor kids trape through and rip it all out. And so this works it works great for trees. Point source irrigation is awful for trees in most cases.
This
Question.
works for trees.
This is great for trees and shrubs, yeah. Question in the back.
Well, so it doesn't matter what kind of vegetables you got in the garden, you're just going off the soil and how you space your emitters.
Yeah, because it's how does the water move through soil? In sandy soil, the water moves more down than it does laterally. In clay and loam soils, it tends to move out laterally a long distance, but not down as fast. So.
Did you say you also do your lawn with this kind?
No, I don't do my lawn with this. No, landscapers used to. It was a fad about 10 years or so, and then it quickly phased out because they can't repair the plugged up lines without ripping up the lawn. So All right, so what I put on here is the lateral line and dripper spacing is based largely on soil type. In sandy soil, you can usually do just fine with 12-inch spacing between the lines and 6 or 12-inch emitter spacing. For clay and loam soils, a 16 to 18-inch line spacing, so you go farther apart, and the emitters can be farther apart, but you're going to run it longer because now we have less emitters per square foot. So we might need to run it for 2 hours instead of an hour. And then for raised beds, which are typically a grow mix or something that drains really, really well, you probably are going to go to a 6-inch line spacing with 6-inch emitter spacing. And this is especially true if you're doing row crops like peas and corn and stuff, because if you're trying to water seeds, young plants, they'll have a very small root system, and you just have wet pockets all the way down. It doesn't work very well because in those raised beds, they drain really well, so the water tends to go mostly straight down and not work its way to the sides very well. So we got to put the emitters closer together so that we create a wet column all the way down. So then you can change plants in and out all the time. Will you go back a slide real quick? Another one. So right here. So this is actually right here in the parking lot of the water conservation where we are right now. Maybe these guys recognize this, but I thought this is a great picture opportunity from this class. So this is actually a really nice point source drip system that will work for trees. Now in this case, the tree's established. These are new shrubs. But you can see that there's actually a drip emitter at the end of every one of these lines. And there's more than one emitter for the large plants. There's at least 2 emitters for the large plants, 1 for the small ones. But you also notice that there's emitters running to blank spaces between plants. And that's so that as the plants grow, as those root systems grow and spread out, they'll be able to move into moist soil. Plants don't grow into dry soil thinking that they'll eventually find wet soil. They follow a wet pathway, and so we have to get those wet zones. We have to get those dripped areas where that water is moving through and being absorbed by the soil. Those have to merge together in order for the roots to really explore that flower bed. So in order to get that to happen, we have to put water in the blank spaces. And if we want to do trees and shrubs a different way, and I see a lot of homeowners, they'll have a juniper, they'll have a tree, and they'll put one dripper right at the base. Well, that's great. That'll work for the first month. What happens when those tree roots are moving out into the rest of the landscape? You got to add more drippers. And the roots are only going to be as big as the moist soil zone that they can root out in. And so that's why I say, you know what, for shrub beds, unless you're willing to run a lot of very well measured and spaced drip lines like this, just do a grid in the whole thing. And then you can add and remove plants and not ever have to mess with the spaghetti tubing, if you will. So it's just another option to deal with it. But you just have to consider these kinds of things for plant health and future survivability. I seriously get calls very frequently with people, and they say, well, what's wrong with my tree? And I'll say, well, how are you watering? Well, I've got a dripper right at the base of the tree. Well, how old's the tree? 3 years? Well, you should probably have 10 drippers around that tree and gradually moving their way out into the rest of the yard, right? So because those tree roots are going to eventually probably take up most of the backyard, so they got to have water in those areas. So question here and then in the back.
Can you tell how far the roots are? Are they pretty much as wide as the tree is?
So that's a good question. How far do roots go in trees? Typically, and I've actually done quite a bit of work on this, and I did graduate work in trees. On an established, mature landscape tree, the roots typically spread 3 to 7 times the diameter of the crown. Way, way farther than the drip line or that canopy edge of the tree. That's why I say if you have a good-sized tree in your backyard, the roots are in the whole backyard and your neighbor's backyards. And their trees will be the same. They'll be overlapping each other throughout that whole area because that's how they keep from tipping over, and that's how they explore the soil to get enough water and nutrients that they need. They don't stay close to home. They don't know boundaries. And so, especially in an area that's really limited like this, if we're not providing away for them to get any other water besides this drip system, then that drip system has to be able to create an even enough water pattern in there that the roots can explore it and the plant will stay healthy.
Do pine trees take kind of the same?
Same thing. It doesn't matter what the tree is, yeah. And spruces and stuff, you see them blow over in the wind all the time. They know the root systems are only about a foot deep. That's actually the case of most of these. Their root systems are generally only about a foot deep. So when they say talk about deep watering trees and stuff, that's marketing. Trees don't need deep watering because almost all the roots that take up the water and nutrients are in the top 6 inches. So that's why if you have a landscaper come in and rip your lawn out and drive all over it and everything, the trees die within 3 to 5 years because they've ripped out almost all the root system or compacted the soil enough during that process that it just kills them. So you had a question in the back I forgot to.
Could you put a loop of the in-line, instead of a point source around a tree, run a loop?
Yeah. Will you go a couple slides forward? That one. So that's just a small loop I put in my pot, but you can put big ones with the 1/2-inch tubing around the trees. Absolutely.
Well, that's what I do in my ground cover. I've got a line out and then I run a loop of the 6-inch spacing in that.
Yep. Yeah, and so what works for trees is just adding every foot. You do a bigger diameter circle out a ways until it emerges at the lawn or wherever, right? Then the roots will move on into the lawn. But at least they're getting that water right closer to home. So that actually works really great. So we just go a couple slides more. I think we're pretty much done here with. So right here, and so again, here's just circled on a round flower bed and a different grid system for an annual bed here. But those make it really nice to add and remove plants without having to move drippers around.